Welcome. I'm thrilled to have you join me on this journey of discovery. Today, we're exploring advanced biohacking, a fascinating and rapidly evolving field. A field that's transforming how we approach health and longevity. We're talking about a paradigm shift in how we understand and manage our well-being. This goes far beyond diet and exercise. While those are foundational, we're delving into much deeper waters. We're talking about working with our bodies at the cellular and genetic level. It's about understanding the intricate mechanisms that govern our health. Imagine upgrading your body's operating system using the latest science and technology. We're talking about precision and personalization. Advanced biohacking is about optimizing health-enhancing performance and extending lifespan by taking control of our biology. It's about becoming the CEO of your own body. Unlike traditional medicine, which is often reactive, biohacking is proactive, preventing illness before it starts. It's about optimizing your body's natural defenses. It's about unlocking the potential within our cells and tailoring treatments to our unique biology. The goal? Not just to live longer, but to live better with more energy and resilience. Picture healing faster from injuries or correcting genetic mutations before they cause disease. It's about optimizing your body's performance at every level. Technologies like exosome therapy and CRISPR gene editing are making this possible right now. These innovations are being studied and applied worldwide, promising more effective, personalized healthcare. This is the future of medicine, available today. We'll break down these complex topics into simple, actionable ideas. I want to make this knowledge accessible to everyone. My aim is to empower you to join the conversation about the future of health. We're on the brink of a new era, one where we can truly partner with our biology. It's a journey of empowerment and self-discovery. Let's dive in. Together, we can unlock the secrets to a healthier, longer, and more vibrant life. Let's start with understanding exosome therapy. What exactly is it, and why is it generating so much excitement in the medical community? It represents a breakthrough in regenerative medicine, offering new possibilities for healing and tissue repair. Our cells constantly communicate with each other. It's a complex and intricate dance of signals and responses. And exosomes are the tiny messengers facilitating this communication. They're like miniature postal workers, carrying vital instructions between them, ensuring that cells function correctly and coordinate their activities. Think of exosomes as microscopic envelopes, carefully packaged and ready for delivery. Each one is filled with proteins and genetic material, the essential building blocks of life. These components are crucial for telling cells how to heal and regenerate, essentially providing the instructions for cellular repair and renewal. Exosome therapy harnesses these natural messengers, amplifying their power to promote healing. The exosomes are usually sourced from young, healthy stem cells, known for their regenerative capabilities. The therapy then delivers them to areas needing repair, targeting the specific tissues or organs that require assistance. It's like sending a specialized repair crew equipped with the tools and knowledge to fix the problem. Imagine them arriving at a construction site, stimulating your own cells to heal, reduce inflammation, and rejuvenate, promoting overall tissue health and function. Unlike traditional treatments, which often involve synthetic drugs or invasive procedures, this uses the body's own language, its natural communication system. This allows it to trigger healing from within, harnessing the body's innate ability to repair itself. When exosomes reach target cells, they merge and release their contents, delivering their message directly to the cell's interior. This prompts cells to act younger or reduce inflammation, depending on the specific instructions carried by the exosomes. The beauty of this therapy is its precision and natural approach, working in harmony with the body's own healing mechanisms. It's about amplifying your body's healing signals without introducing foreign substances, which can sometimes trigger adverse reactions. As a cell-free therapy, meaning it doesn't involve the transplantation of entire cells, it offers the benefits of stem cells without the risks of cell transplantation, such as immune rejection. Exosome therapy is a prime example of biohacking, a field dedicated to optimizing human health and performance. It's about working with our biology, not against it, to unlock new levels of health and well-being. Exosome therapy is already making waves in real-world medicine. In sports injuries and joint pain, exosome injections deliver healing signals directly to damaged tissue, speeding recovery and reducing pain. In aesthetics, Exosome facials stimulate skin cells to produce more collagen, resulting in firmer, younger-looking skin. Researchers are exploring exosomes for neurological conditions like Parkinson's and Alzheimer's, hoping these messengers can cross the blood-brain barrier to repair brain cells. Exosomes are also being studied for hair restoration and healing chronic wounds in diabetic patients. The common thread? Using the body's own communication system for targeted natural healing. This elegant approach is already changing lives and holds even greater promise for the future. Exosomes are versatile tools, guiding the body's repair processes exactly where they're needed most. Now let's delve into CRISPR-Cas9, a truly revolutionary gene editing tool that has transformed the landscape of biotechnology. Think of your DNA, the very essence of your being, as an encyclopedia of instructions, a comprehensive guide for your body, dictating everything from your hair color to how your cells function. Sometimes, however, there's a typo, a mistake in the genetic code that causes disease, disrupting normal bodily functions. CRISPR-Cas9 acts like a biological find and replace function, a precise tool for editing the genetic text, allowing scientists to correct these typos with remarkable precision and accuracy. The CRISPR part is like a GPS, a navigation system, programmed to find the exact gene needing repair with pinpoint accuracy. Cas9 is the molecular scissors that cut the DNA at the targeted spot, ensuring minimal disruption to the surrounding genetic material. Once the cut is made, the cell's natural repair system, a built-in mechanism for maintaining genetic integrity, takes over, either disabling a faulty gene, preventing it from causing further harm, or replacing it with a healthy one, restoring normal function. This process gives us the power to rewrite the code of life, to correct errors and improve health, potentially curing diseases at their source, offering a more permanent solution than traditional treatments. In simple terms, design a guide to match the faulty gene, ensuring precise targeting, deliver it with Cas9 into cells, make the cut, and let the cell repair itself, utilizing its own inherent mechanisms. CRISPR's precision is what sets it apart from older gene editing methods, offering a level of accuracy previously unattainable. It opens the door to treating genetic diseases, fighting cancer, and more, offering hope for previously incurable conditions. The technology is rapidly advancing, making gene editing more accessible and accurate, empowering researchers worldwide. With CRISPR, we're not just managing symptoms, we're addressing root causes, tackling the underlying genetic issues. This is a game changer for medicine and human health, offering unprecedented opportunities for treatment and prevention. Let's see how it's being used in real-world applications and research. CRISPR's potential is staggering. It's already being used to treat inherited disorders like sickle cell anemia by correcting faulty genes in a patient's own cells. In cancer, CRISPR can supercharge immune cells to better recognize and destroy tumors. Scientists are also exploring CRISPR to target and eliminate viral DNA, offering hope for curing infections like HIV and hepatitis B. Beyond medicine, CRISPR is being used to develop resilient crops and new antibiotics, and even to control disease-carrying mosquitoes. The common thread is precision, targeted changes to DNA that were never possible before. This accuracy unlocks solutions to some of humanity's biggest health and environmental challenges. CRISPR is rewriting our future, one gene at a time. The possibilities are just beginning. Let's compare exosome therapy and CRISPR. Exosome therapy is about communication and regeneration, delivering natural signals to heal and reduce inflammation without altering DNA. It's like coaching your cells to perform better, ideal for tissue repair and managing inflammation. CRISPR, in contrast, edits your genetic code directly, correcting or disabling faulty genes for permanent solutions. It's the master editor, offering cures for genetic diseases and some cancers. Exosome therapy's main concerns are sourcing and purity. Quality control is key for safety and effectiveness. CRISPR's challenges are deeper, avoiding off-target edits and navigating ethical questions about altering human DNA. While exosome therapy works with your biology, CRISPR rewrites it. Both are powerful, but each has unique strengths and risks. The future of medicine will likely combine these tools for maximum benefit. Understanding their differences helps us use them wisely. As gene editing advances, safety and ethics are paramount. The main technical challenge is preventing off-target effects, unintended DNA changes that could cause harm. Scientists are improving CRISPR's accuracy and using computer models to predict risks before treatment. Long-term effects are still unknown, so clinical trials are cautious and thorough. There's a key ethical distinction. Somatic cell editing treats one person and isn't inherited, while germline editing changes DNA for future generations. Most experts support somatic editing for serious diseases, but germline editing raises concerns about designer babies and genetic inequality. There's a global moratorium on clinical germline editing until society can agree on clear guidelines. The conversation about how to use these tools responsibly is just as important as the science itself. We must balance innovation with caution and ethics. Advanced biohacking is ushering in a new era of personalized medicine. Soon, treatments will be tailored to your unique genetics, cellular health, and lifestyle. Exosome therapy could become routine for recovery and inflammation, customized to your needs. Imagine correcting genetic risks at birth with a single CRISPR treatment. True preventative medicine. AI and diagnostics will help pinpoint problems, guiding doctors to the best biohacking tool for each case. The goal is to extend not just lifespan, but health span. Years lived in good health. This future empowers individuals to take control of their biology. The revolution in health is happening now. We've explored the frontiers of advanced biohacking, from exosome therapy to CRISPR. These tools are helping us move from treating symptoms to addressing root causes, unlocking our body's potential. The future of medicine is a partnership between scientists, regulators, and informed individuals like you. Staying curious and engaged makes you part of this transformation. The choices you make today lay the foundation for tomorrow's breakthroughs. We're living in an extraordinary time with the power to redefine health and aging. Stay hopeful, stay informed. The best is yet to come. Thank you for joining this journey into the future of health.